Hi, year eights. Hope you're doing well. So I've just had the drop-in session. So unfortunately, I think Jack was the only person that came along to that. So thank you to Jack. Otherwise, no one's coming along to those. So I know it's maybe sort of forgetting the timings, but it would be really good if people could come along so you can just ask any questions. You know, if we have about sort of 5, 6, 7 people, we can have a little discussion, ask a few questions, and just generally get a bit more out of it than hopefully these YouTube videos. But I will go through some of the stuff I was going to go through on the YouTube videos anyway. So I'll do a little bit on the inverse proportion, a little bit on the recipe problems, and then go from there, and hopefully that will help. So I'll start off with the inverse proportion and hopefully answer some of the questions from the hegarty and the worksheet. Okay. So if we look at these questions, now this first question, so this question is asking, actually I'm just going to flip it this way. See if that helps. If 6 workers take 700 hours to finish a project, how long will it take 12 workers? Okay, so if 6 workers take 700 hours to finish a project, how long will it take 12 workers? So the idea behind this is inverse proportion. So what we've been looking at before is something called direct proportion. So with direct proportion, if I was going to walk into a shop and I buy 2 Mars bars, that's going to cost me, let's say, £1. If I then buy 4 Mars bars, it's going to cost me £2. If I buy 8 Mars bars, it's going to cost me £4. So the more I buy, the more it's going to cost me. But if we were, in class and I asked one of you to give out the books, that might take you 4 minutes to do. If I asked 2 of you to do it, you'd hope that if there was 2 of you doing it, it would take half the time, because 2 of you are actually putting in all that sort of that time together, so you get it done twice as quickly. So a lot of inverse proportion questions are actually where, say, for example, this question where you have some workers doing a project, how quickly can they do it? And it makes sense that, for example, I'm looking out over at the new build here. If there was only one lonely builder working on the new build, it would take him years and years and years to finish that building. But the more workers there are, the quicker that building will get done. So that's the basis behind inverse proportion. That's why we think about inverse proportion, because sometimes things don't go up together, like price, the quantity of things you buy and the price, they go up together. However, the amount of workers goes up, the amount of time that it will take will come down. Okay, so that's why we're looking at that. And the way we do this, so what I'm just going to look at, if it takes 6 workers, so I'll put 6 workers, I'm going to put it in this little ratio format. 6 workers can take 700 hours. So 6 workers can take 700 hours to finish a project. How long will it take 12 workers? So I'm going to write 12 workers here. So 12 workers there. And what I've done to get from 6 to 12 is I've times it by 2. Hopefully we can see we've times 6 by 2 to get 12. Now what I'm going to do on the other side, because it's inverse, I've spotted that because it's workers and it's kind of how many hours it will take, the more workers we have, this will go down. Therefore, where I've times this by 2, if it's inverse, I'm going to divide this side by 2, because if I've doubled the amount of workers, there's going to be less people, less hours that it takes. Okay, so we'll have twice as many workers but less hours. So I'm going to do 6 times by 2 to get 12, so 700 divided by 2 will get me 350 hours. So it's taken me 350 hours with 12 workers. So this is the format that you can do. Just write it out like this. Write out the new bit of information you have here. And if you have times this, you are going to divide on this side. Before we were doing the same thing to both sides. When it's inverse, we're going to do the opposite function. If we're timesing by 2, we're going to divide by 2 on this side. Okay. This question, if it takes 7 workers, 12 hours, how many workers are needed to make it in 3 hours? So let's write this one out. So we've got 7 workers there, and it's taking them 12 hours. Okay, so 7 workers, 12 hours. How many workers are needed to make it in 3 hours? So this time my new bit of information is here. So I've just got to work out what is going to go here. How many workers it takes for 3 hours? Well, if it's 12 hours to 3 hours, 12 to get to 3, I've divided that by 4. 12 divided by 4 gives me 3 hours. Therefore, on this side, if this is a divide, I'm going to times this one by 4. I'm going to times this by 4, so 7 times by 4 will give me 28 workers to get it done in only 3 hours. So when we notice that it's inverse, we're just going to be doing the opposite on each side. If I'm dividing by 4 there, I'm going to times by 4 on that side. Okay. Now this question is going to be slightly different just because we're not working with as nice numbers. In these examples we were dealing with divided by 2, times by 2, divided by 4, times by 4. It's not going to be as nice numbers here, so we're going to use a different technique slightly. So if a tap fills a bucket up in 14, I think that's meant to say litres per minute, let's say. Yeah, litres per minute. Oh no, sorry. Okay, sorry. A tap fills a bucket up in 14 hours, dripping at 18 litres per minute. How long would it take it if it was dripping at 71? Oh no, sorry, 7 litres per minute. Helps if I can read my own handwriting. So we've got 14 hours dripping at 18. So I'm going to do 14 hours, and that's 18 litres per minute. So the new bit of information I want is how long it's going to take me to get from 7 litres per minute. Now what you'll notice is that 7 and 18, we don't have nice numbers here. If this was 9, we would know we divide 18 by 2 to get to 9. But because it's 7 doesn't go neatly into 18. Now, there will be, a fraction decimal that we can divide here, but that's not exactly going to be the nicest way of doing it. We might make a few mistakes. So what I'm going to do, I'm actually going to work out, first, I'm going to work out 1 litre per minute. So I'm going to take what I know and I'm going to take it down to 1 litre per minute. How long is that going to take me to fill it up? So to get from 18 to 1, I'm dividing 18 by 18 to get to 1. So divided by 18. Therefore on the other side, I'm going to do divided by 18. Oh. Sorry, I feel like someone's trying to call me on Teams, but I don't know how to answer it. So I'm going to ignore it. Okay. So if I have, 18 divided by 18 will get me to 1. On this side I've got 14. I'm going to divide by times by 18, because I've done divide by 18 on this side, times by 18 on this side. So that's going to be 14 times by 18, which will give me 252 hours. So 252 hours is 1 litre per minute. So now I've got where it's 1, I can then find out how it's going to be, how long it's going to take if it's 7. So if I've got 1 here and I want to know about 7, I can then times that by 7, times it by 7, and therefore on this side what I'm going to do is I'm going to divide by 7. If I'm timesing by 7 there, I'm going to divide by 7 on this side, which is going to leave me with 36 hours. So it's exactly the same process. The two most important parts about this, on this side, if I'm dividing on this side, I'm timesing on this side. But with this question, because it wasn't nice numbers, I found out 1 initially, and then so I've divided down to get 1, and then I've times to get the number that I wanted here. So I've divided by 18 and then times by 7. So we've just added in that step when we have that 1. Okay, hopefully that helps. I'll leave this for the inverse proportion. These hopefully go through a lot of the questions. So I think these couple of hegarty, this one's off the worksheet. I'll do a quick video on recipe problems, and hopefully that will be really helpful. All right, thanks.